So thanks everyone for standing by and welcome to today's webinar where we'll be previewing Terraform Cloud GA and walking through some exciting new features that are coming in our September general availability. My name is Caroline Guo and I'll be helping facilitate today's webinar. Throughout the webinar, feel free to type any questions in the question box, and once we get to the live Q&A section, we'll go through some of those and get those answered. This webinar is also being recorded, and the recording will be sent out and made available within a couple days just for post-processing. And then with that, our speaker today is Rosemary, who's the developer advocate for HashiCorp Terraform. Please feel free to reach out to her directly after this webinar as well if you have any questions to follow up. And now let's get started.
Awesome. Thanks, Caroline. So welcome to a preview of Terraform Cloud. It's really exciting. There are a couple of new features that we wanted to cover and talk about, and I'm really excited to actually do a bit of a live demo for them. So hopefully everything works today. Anyway, who am I and why am I standing here talking about Terraform Cloud? Well, as Caroline mentioned before, I'm a developer advocate at HashiCorp. You can find me on various social media platforms. I focus quite a bit on Terraform, although I do have other focuses on the other tools as well. So if you ever have questions, feel free to reach out, or you can also post on our community forum, which we will always be there to answer some questions if you have them. So what we're going to cover today is a rough idea of what Terraform Cloud is, why we released it, and there's a remote state management feature that is already generally available for use, but we also have some automation and collaboration features as well. We're going to go through a bit of a demo, and the demo will cover the remote plan and apply, so that's a new generally available feature. We'll also have some VCS integration discussions. We'll talk a little bit about pull request automation, and we'll talk about the private module registry. And as Caroline put it out, we'll proceed to Q&A. So if you have questions, feel free to post them into the control panel. All right, so we'll start with what is Terraform Cloud exactly? Well, Terraform Cloud is sort of the build on top of Terraform open source that we thought about, right? So if you use Terraform open source, you'll basically download the open source binary, you'll configure your local machine to use it, and you'll manage your state file locally. This is kind of tricky though, right? Because imagine if you accidentally deleted that state file, you've now orphaned some infrastructure resources somewhere and you don't know where they are and you don't know how to clean them up. And so when you continue doing this, it becomes a little bit more difficult to scale, especially when, let's say, another individual wants to collaborate with you. So in your team, maybe in the Terraform open source, you'll download the open source, you'll track the version really carefully, and maybe you'll freeze the version. I did a brief discussion the other day about upgrading Terraform, and some people are still tracking and hardened to a specific version of Terraform, and you have to be very careful about that, right? So you'll manage your state file maybe. That could be done remotely, that could be done locally, but you start to add some storage versioning. If you're using buckets, you'll turn on that versioning feature to make sure it's always backed up and versioned. And you'll encrypt that to make sure that maybe no one can just access the secrets in that state file, for example. And then maybe what you'll do is start by configuring it from your local machines. You'll run Terraform plan, Terraform apply locally. But then you realize, this isn't really infrastructure as code. This really isn't the workflow that we as a team want to adopt. So we'll start building some automation wrappers around Terraform and load that into our CI framework. I have been very guilty of this. But the idea is that maybe you're using a CI framework and you'll start to build some wrappers around it, or you'll start to build some scripts just so that you can run Terraform plan and Terraform apply in some kind of pipeline in your CI. So that's kind of what happens in the open source version of Terraform, and it works. It's great. We've done it for a while, and for teams, it's great because you still get the benefits of Terraform and infrastructure as code, and you get to do this in a pipeline form. But there were some key parts that were kind of missing when we started to scale this out, right? Eventually, you start building a bunch of repositories, specifically some kind of code repository to house some shared modules. So a great example of this would be like networking, where maybe you depend on that and you want to make sure that it's standardized configuration. So someone else can use this module for provisioning some networking. And that kind of gets stored in some code repository. Then you also have to build a bunch of state file management on top of that. So we would write hundreds of lines of code to basically bootstrap some buckets, turn on versioning, make sure access logs were being streamed, making sure that access was locked down to it, making sure that we were prefixing it, we were standardizing on the naming, we knew where we were writing to. So state file management was a little bit tricky. And then remote operations, as I pointed out before, we maybe had to put this into a CI framework and make sure that we could execute this remotely. I mean, let's be honest, it takes some time to spin up infrastructure resources. If you're spinning up, for example, a Kubernetes cluster in GKE, even that takes quite a bit of time. And let's say you close your laptop after you're done, well, that remote operations may not continue, right? So the idea is that you would put it in the CI framework. So these three key pieces were really essential for Terraform to scale in a team. The idea of being able to share modules within your team that is specific to your organization, but also manage the state correctly, properly, version it, encrypt it, but also being able to execute the Terraform plan and applies when you need to, without needing to worry about something happening locally, is really important as more and more people start to use Terraform in your organization. So with these three pieces, right, this becomes the groundwork for Terraform Cloud. The feedback that we got before, as we talked about previously, was that Terraform wasn't that easy to collaborate with. You had to build a lot to make it easy to collaborate and scale within your team. So Terraform Cloud is automation and collaboration for all. For individuals and teams, you would create a Terraform Cloud account. You connect to reverse and control whatever you decide to use. You collaborate, whether it be in the UI or API. The API you can use to automate yourself if you want, and you can provision it to any provider that you're looking for, so long as there is connectivity, right? So if you have your SaaS to, you could even connect this Terraform Cloud to on-premise if you want, if your on-premise has connectivity back to Terraform Cloud, for example, right? So it is a SaaS offering. It solves these challenges about state management, versioning, and general collaboration. It handles the remote operations, it handles the state storage, and it has this ability to host your modules if you want, so you can share them across your team. So the idea is that it makes it a little easier to collaborate on Terraform. It's a little bit less complicated. You don't have to build a bunch of automation scripts now so that you can run Terraform plan and Terraform apply and build your infrastructure or configure your infrastructure. So what did we release to start? Well, we started with remote state management. Basically, it's remote storage of your state. It gets really difficult with remote state sometimes. I actually went through and refactored a repository of mine that was deploying to AWS, and I think I got rid of about 200, 300 lines of code that had to do with bootstrapping a S3 bucket and then creating policies around it to lock it down and then adding encryption. And I had to get the keys set up. So this whole sequence of things starts to go away, and it eliminates a lot of the overhead of trying to figure out what to do with that state file. It also supports locking. So if you are collaborating on a plan and someone else is also doing that, the remote state management capability in Terraform will lock that state, so that there's no cross conflict, so to speak, of the plans and configurations. And you could also audit and view a history of changes as well. So it does provide a nice view of state, and it provides a history of any changes that someone might have made to it. So that's something that's really neat within remote state. This is actually generally available now. But there are actually many more features that we're looking to open up in September, and a few of them are listed here. So from an automation standpoint, we're basically offering the infrastructure as code capability that exists in Terraform. So using HashiCorp configuration language or JSON if you desire, you can define a topology of infrastructure resources. So that stays pretty much the same, except it's doing it pretty much remotely, right? So VCS connection is the second automation feature that's really neat, and we'll cover a little bit of that today. The idea is that we automatically validate configuration changes and trigger Terraform. So this is something like git push, and then it just triggers Terraform to run against that repository. So it's really nice to see that. Remote operations is also pretty useful for long-running provisioning steps, for example. So you plan and apply, and it triggers that remotely, and you'll be able to see that either in the UI or with another API call. And there's also access to the full API. So if you want to build your own tooling, build your own automation around that, you are more than welcome to take advantage of that API and use it, right, for whatever automation you want. So those are some of the key automation features that we'll cover a little bit of today. And there are also some collaboration features. So these are more specific to how you collaborate using Terraform. We have remote state management, and I mentioned that before, but we also have collaborative plans and applies. You can review your team plans and changes. You can actually make comments as well. You can take a look at who's issuing what changes and how. So that's actually something really neat that you'll be able to see as part of your team. There's a full user interface, and it's most of the time when we use Terraform, it's automated, but let's say you have someone who wants to take a look at who issued what. For it could be SOX compliance, it could be something else. The idea is that you want to have a neat view of who has applied changes. You can go in and look at that user interface. And if you want to use shared modules within your organization or your team, you can leverage our private module registry. So what this will do is organize a private configuration that's only accessible to your team. We already have a public registry available, and those are contributed from the community. Big thanks to them. But let's say you want to build on top of that, or there's something very specific to your organization. You can put it into your private module registry, and it's a very similar experience as if it was in the public module registry, just within your team. So it's really nice to collaborate with that as well. All right, so here's the good part. So let's get to a demo, right? There are going to be a few things that we're going to go through today, and you'll get a feel for what they look like. First, I'm going to go through the remote plan and apply. I'm going to talk a little bit about the VCS connection. So if you have GitHub, GitLab, Bitbucket, there's a VCS connection that you can make back to your VCS provider, and then you can hook that up into a Terraform Cloud workspace. We'll explain a little bit of that. We'll go through about a little bit of pull request automation. It does take some time to run it, so I may not go through all of it end to end. I'll just demonstrate sort of what it might look like from a workflow standpoint. And then the private module registry. So we'll talk a little bit about what the private module registry can offer, and I'll go through how it might be set up. All right, so let's get started then. I'm going to swap screens, and we're going to start by actually examining the Terraform Cloud. So before you log into Terraform Cloud, you'll need an account. You'll have to click this sign up page. So you go in, you sign up, you add your email, you add a username, etc. And then your administrator for your Terraform Cloud organization will add you. So it's under organization settings. The admin will be able to add your username to your specific organization. So Terraform Cloud has some organizations here, as you can see. I'm in HashiCorp TF Cloud Demo. And organizations can sort of be logically divided into workspaces. So workspaces provide you the opportunity to isolate state, variables, environments, right? And so you can apply configurations within the context of a workspace. So here, as you can see, I have a few workspaces already, but I'll go through a little bit of what happens when you start using this, right? So let me actually go back here. I have a module that will deploy to Azure. And basically what I'm going to go through in this particular demonstration is remote plan and apply. So let's say you're not really ready to do CI/CD or continuous delivery of your infrastructure. You're not quite there yet. Maybe what you're doing is running a Terraform plan every once in a while. So what I'm going to do is I'm going to actually examine this backend configuration here. So this backend configuration is very simple. It just says I have an organization Let me just make sure it's big enough. And then, so it has an organization and it has a workspace. Specifically here, I'm going to call it TF Cloud Demo Azure. Very simple. And this is an explicitly defined workspace name, which is great. So what I'm actually going to do is that if I look into my Terraform stanza, in this case, I'm using 0.12, by the way, I actually can declare something called backend remote. This will default point to Terraform Cloud at terraform.io. So once I configure this, I'm actually going to just run a Terraform init. And when I run this Terraform init, what it will do is actually initialize my backend for me. Now the question is, where is this backend going? Well, we did configure it to go to remote. So when I go back to my Terraform Cloud, I should see a workspace called TF Cloud Demo Azure. So what this has done is once I issue an init, it will initialize my workspace for me. Something important to know, though, about these workspaces is that they don't have anything in them, right? So they're initialized blank slate. You can configure them, using Terraform yourself or using the API. So what we're actually going to do now is just take a look at some of the settings that you can customize. So in general settings, you'll notice that I've defaulted my blank workspace to remote execution mode. This means that my remote plans and applies will happen in Terraform Cloud. If you're using remote state management today, you may want to check your execution mode when you reinitialize a new workspace and apply local, right? Because local means that your plans and applies occur in the machines within your control. So just as a note, if you want to continue doing local execution, you'll need to go into settings and click local execution. Next, you can also see there's auto apply, manual apply, so you can go ahead and choose whether or not you're going to auto apply and go straight to the applied changes, or you want to manually approve them. You can also specify the Terraform version and the working directory if you want to execute in a specific directory. So this is more related to VCS, for example. So we'll go through that later. But just as a quick note, here are some of the settings that you'll actually look at. And one of the most important aspects of our workspace is populating the variables. So when you initialize a workspace, it's not going to default populate the terraform.tfrs up for you, right? Your terraform.tfrs or whatever your Terraform variable files are locally will not just be automatically populated up here. You'll add them via the UI or the API. So what I'm actually going to do is show, here I'm going to add them with the UI. I'm just going to do this. So here I'm just going to add my CIDR block, which seems a little tedious because, who wants to sit here and copy and paste into the UI? But it works out if you, for example, have very minimal configuration and you want to be able to add that in. And something important as well is that as I add these values, there are some flags here. So there's HCL. So if, let's say, it's an HCL block, I can let Terraform Cloud know that it's HCL syntax. Or if it's sensitive, it will mask it for me. So actually, I'll show a little bit of the sensitive variables, right? So in Azure, I need to be able to provision to resources using a client ID and client secret. However, I really don't want other people knowing this client secret and client ID. After all, I'm on a webinar and anybody can probably grab these, so I'm not going to do that. But what I'm doing is I'm actually using the Terraform Cloud API to push up these sensitive variables that I've read in via my environment, right? So here I've actually pushed that up. Notice that the sensitive is true, so it's not going to output the value. And if I actually look in Terraform Enterprise, Terraform Cloud in the UI, what you'll see is that the client ID, secret, tenant, and subscription are all sensitive write only. So I will not be able to read this, and someone else in your team won't be able to just go in and read that. So you could go ahead and actually mask some of your sensitive variables there. All right, so we've done all of that, right? Which is pretty good. And now I'm actually going to go back and do what we all would do in the open source version, which is Terraform plan. So when I run a Terraform plan, what this will actually do is kick off a plan in remote backend. And you'll be able to see the run with this particular link, for example. So if I go back to my Terraform Enterprise, you can actually check the state of the run with this URL. As you can see here, it's running and my variables have automatically populated. So you remember the CIDR block that I put in? The CIDR block is getting populated into my plan. And that's because it's getting picked up within the workspace variables. So now that I've gotten it picked up in workspace variables, what I'll actually do is now apply it. This is pretty much the same workflow that I would do if I was in the open source and I was running this locally. The difference is that it's running upstream in Terraform Cloud. So right now I'm just waiting for the plan to start. And after it's finished planning, what it will do is actually ask me for confirmation, right? So just like a Terraform apply would do on your local CLI, it will ask you for confirmation. Do you approve of this particular plan? And I can say yes on the CLI. Well, fun fact, this triggers an actual API call up to Terraform Cloud. So what you'll see is here, it says waiting for confirmation, and I could click confirm and apply in the UI if I wanted to here. But instead of maybe I'll just say, I just want to use it on my CLI, I'll just say yes, right? And what this will do is send an approval through the API up to Terraform Cloud, and we'll proceed to apply the infrastructure. So as you can see here, the apply is starting to run. And eventually this output will also get streamed back to my local terminal. So if I, let's say I close my terminal, for example, I can always go back to the user interface and ensure that my apply has completed. So that's a pretty neat example of what you might do if you were, maintaining your local workflow. You don't run it very often, for example, and you still want to use the Terraform plan, Terraform apply, but you just want to trigger this remotely. This is able to connect to Azure, of course. However, if you're connecting, if you're firewalling, etc., just make sure it's open for Terraform Cloud to connect to it, right? So as this is creating, I'm actually going to talk a little bit about VCS, right? So most of the time when we're doing infrastructure as code, we want to be able to commit code to a specific place, to a repository of our choice, and automatically trigger a run. So what we're going to actually do is show what the VCS looks like. You'll have to configure VCS settings under the VCS provider. Here you'll have to add a VCS provider and configure OAuth, etc., etc., etc. But once you do that, you will actually be able to apply it to a workspace. So in this particular example, let's say I have some production infrastructure. And this production infrastructure is just some Kubernetes cluster running in Google Cloud. And let's say I want to make changes to the production infrastructure, but I'm not feeling too confident about those changes. So what I'll do is maybe I'll create a mimicked infrastructure in QA, and I'll call it QA, right? Just to make sure that my changes are good. It's mimicked infrastructure, as you can see here. Notice that I've separated production into one workspace and QA into another. Each have different variables, and each also have different states, right? So the idea is that they're not, mixing and matching state. And by different variables, QA just has a different cluster name, but all of the other variables pretty much remain the same. So what I'll actually do is, let's say I want to take the QA branch and make some changes to it and just test if things work out. What I've already done in the QA branch is configure version control. So if I actually go through this, I can actually update my VCS connection. It will neatly ask me for the repository. I can choose the one that I want to use, and it will actually confirm my changes and apply it. And this working directory gets picked up under my general settings that I've already pre-configured, so that's pretty neat. Right now, I'm actually not configuring a VCS branch because my repository doesn't really have a QA branch yet. So what I'll actually do is go back to my QA branch. Let me just get back there, and I'll check out my existing branch, right? So I've already created a mimic. I'm just going to push it. And what this will do is allow me to just say, okay, I can add now my VCS branch. And the really cool part about this is that it actually will pick up whether or not that branch exists. So through that integration with the VCS provider of your choice, we're able to say, okay, this branch exists, here's where it is. So now that I've gotten actually a mimicked infrastructure, I've set up a branch that has some QA that mimics my production, I can now start to configure my changes and test that they work. So what I'll do is I'll actually just add a subnet. This is a really simple thing to do, not anything terribly complicated because I don't want it to take too long. But what you'll see here is that it's going to create a subnet backup. So all it's doing is just adding a subnet. The Kubernetes cluster sits on a subnet right now, so I'm just adding a backup one. But it does it pretty quickly. So just for the sake of an example. So what I'll actually do is then commit this new subnet, and I'll actually push this to QA. And if my VCS has been set up correctly, which hopefully it has been, this will trigger a webhook that will basically allow Terraform Cloud to execute a run of said change. So let's see, take a little bit. There we are. So notice that my current run has my commit message, right? It has new subnet and it has my commit hash on this. And what it's really saying is that in the QA infrastructure, I have made this change. So this is really what the infrastructure as code piece is about. So if you're collaborating on a configuration, you'll be able to push to a specific branch and it will execute if you've got that VCS integration in place. So let me just confirm. You can actually auto apply if you want as well, but in this case, it will default to a manual apply. So I'll just confirm and apply. You can make a comment if you want and confirm plan. So what this will do is apply my changes to my QA environment. So as this apply runs, let's say I've checked through it, I've ensured that it's not affecting anything. Really what I'm looking for is, this subnet isn't going to change anything, right? I'm not destroying anything. I'm not changing any other resources. It really just should be adding a new subnet. So this plan allows me to confirm that, and I can apply it. So when this is actually happening, what I'll actually do is start with a pull request. I'm feeling pretty confident that this is actually an okay configuration. So I'll actually create a pull request and merge this back into my master. So what this is doing is saying, okay, I'm going to say this is a production ready configuration. I'll just merge this back in. And I will create a pull request. Notice that when I create a pull request, it actually generates a set of checks. So what this is doing is going back to Terraform Cloud and saying, hey, did this actually work the way that I expected to? So you've got some details here. I can go and look, and this actually says, oh, my apply actually finished, and my plan was successful. So all of these things are great. Now, this doesn't mean that, there's some other things that you might need to add in terms of checks, but here, basically saying, okay, I'm doing all the checks, everything generally looks good. You'll also notice that it triggers a plan on my production workspace. This is what master is, right? Because I'm merging to master. So in my production workspace, it's triggered a plan. It doesn't apply it, but it allows me to view whether or not the plan is actually consistent with what I looked at before. So here I've got all of my checks passing. So what I'm going to do is I'm just going to merge my pull request. And notice this is pull request number 10. So I'm going to confirm my merge. And what you'll see in Terraform Cloud is production is actually planning. So what this is effectively doing is saying, okay, my merge request has been successful. So now I'm going to trigger my branch master to rebuild production. So here you'll notice that it's actually going to be running, and it's going to wait for my confirmation once again. Something to note is that when you configure VCS integration on a workspace, you will not be able to run Terraform apply or destroy locally. So that's a key note, right? You won't be able to do that, because it's expecting you to make commits in order to maintain the correct kind of parity, right? So you won't be able to just make like a quote unquote manual local change and then push that, and then actually apply it with Terraform. You'll have to push that up as part of your Git repository. So you'll have to be able to do that. So I'm just going to confirm and apply, say, okay, this is ready to go. And actually what I'm going to do is now, now that I've done, I've applied it to production, I've kind of already tested it in QA, maybe I don't really want QA, it's an ephemeral environment. So what I'm going to do is I'm going to go back and delete it. Something important to notice about Terraform Cloud is that you won't be able to delete workspaces or infrastructure in workspaces by default, right? This is a good thing because if you have production infrastructure, you wouldn't want someone accidentally saying destroy and delete, right? So to be more intentional about whether or not you are going to delete some infrastructure, you have to add an environment variable called confirm destroy. So you just set confirm destroy to 1, and this will allow you to destroy the infrastructure in that associated with the state of that workspace. So here you'll notice like I have a couple of states that have been triggered as well. So it will only destroy the infrastructure noted in this state that is associated with my workspace. So I'm only going to destroy the QA stuff. So what I'll do is I'll go to settings, destruction, deletion, and I'm just going to queue a destroy plan. And it's the same idea as a Terraform destroy, right? So we'll plan, show me what's going to be destroyed, and then I can confirm and apply that destroy. Only after I've done this should I delete the workspace. If you delete the workspace before running the destroy infrastructure step, you may find yourself with some infrastructure kind of sitting out there and that's not being used. So keep in mind, destroy your infrastructure before you destroy the workspace itself. I'm just going to confirm and apply and destroy that workspace. So this is not something at least the confirm destroy variable, it's not something I've set on production. I've only set it on QA specifically. So if you take a look here, oh no, sorry. But the idea is that by default, this is not going to be set. So here we go. Basically, this is the entire workflow of VCS integration. All right, so last bit, this is a quick one. You'll notice here at the top, there's a tab called modules. In modules, what you actually are going to see is a couple of configurations. You'll be able to sort of add modules from public, but let's say you're working within your organization and there's a really specific networking configuration you expect people to use. And this networking configuration maybe has VPN stuff in it, right? Or maybe it's some alerts that you want to configure and it's a base library of alerts that you might want to distribute and have everybody use. So in this case, let's say I have a very standard Kubernetes deployment module. So what it will do is just deploy to Kubernetes, but I want everybody to use it because it's a little bit more useful, but it also helps me from an automation standpoint to audit and see, kind of who's doing what with the module. So I'm actually going to go and first configure my module. So that's actually kind of important. So as you can see here, I have a Terraform Kubernetes deployment module. If I look in this module, really all it has is deployment, namespace, service, and it has a name. If you create a private module, you do need a name. That is kind of part of the standard. Let me just make this a little bigger so everybody can see it. On top of that, you also need to specify your variables, so make sure you have that. And I don't have them here, but if you have outputs, specify your outputs as well. Always good to have a README. So it's a little bit like you just want to standardize some of your module development practices. On top of that, Terraform Cloud expects your module to be named Terraform dash whatever the provider is dash name of the module. So in this case, I'm naming it Terraform Kubernetes deployment. And what I'm actually going to do is tag this. You have to tag your repository. And so this is where you say, okay, git push origin v001. So I'll tag this as version 001, make sure it gets pushed up. Let's see. So what I'm doing here is I'm going to push this up. This is actually pushed to GitLab. So for example, so a different VCS provider. So if I add a module here in Terraform Cloud, I've already pre-configured my GitLab connection. So what it's going to do is look in GitLab for a specific repository. And as you notice, my module source repository is already in there. So I'm just going to click that. Notice this also tells you that you must have the format of organization/Terraform provider name. So keep that in mind. And all I do is click publish module. And what this will do is read all of the variables, read the readmes, read the outputs, and basically organize this in a really neat page that I'll be able to see sort of what are the things that I need to run, what are the resources that it might define, how it's being defined. So it's really straightforward in some ways to go in and say, okay, this is actually my module, this is the shared resource, this is how I use it. So it's very similar to how you would see it in the public module registry, for example. And within your organization, let's say you want to use it, you can actually just add source, this app, Terraform IO, your organization name, and the name of the module. So really, if you want to distribute this to someone else in your team, they just need to include this as part of their Terraform configuration, and it's then theirs to use. Of course, they have to be part of the organization or the team, and so that's kind of the offering that Terraform Cloud will provide. So it's, in some ways, a lot of this is pretty easy to set up. So if you're, let's say, you don't want to invest the time to necessarily building a bunch of pipelines, et cetera, and you're looking for something that's offering a way for you to run Terraform really easily and collaborate within your small team, this is pretty useful. So that's actually the end of demos. Let me go back to slides. All right, so in short, some of these features are pretty cool. The idea is that you can remote plan and apply. So let's say you don't want to run this locally, you have something long running, provisioning, sort of like as whatever Azure components or AWS components or GCP or whatever components you decide that's pretty long running, remote plan and apply. It's really useful. We also have the VCS connection available, so you can connect to a variety of the VCS providers. You can use pull request automation. You can even use trunk-based if you want. If you decide you want to commit to trunk or master directly, and it's a small change, and you just want to see if that workspace is good, and then you could promote to the next workspace, for example. Private module registry is another great feature that we'll just be able to share the modules within our team, especially if they're standardized, less duplication, and we're all a little happy about that, right? All right, so in terms of resources, what can you do, or what can you do to learn more about Terraform Cloud, or what information is out there? Sign up for Terraform Cloud today. There's a sign up link right here. And get started with Terraform Cloud. There's a great learn guide that talks about how you get started, what you get started with, and it gives you a quick introduction of how to set everything up locally. There is some setup locally that you'll have to do. And also we'll tell you a little bit about all of the constructs in here. So organizations, workspaces, etc. And there's a blog that talks about using Terraform Cloud Remote State Management. While it focuses on remote state management, it's got good resources on how you get set up. So it's a good start, and then you can use that to kind of jump off and try some of the other features here. Well, thanks for listening to this today. I'm glad the live demo went, and I'll pass it back to Caroline and open the floor for questions.
Awesome. Thanks so much, Rosemary. Yeah, so we're going to transition over to some Q&A. There's been a lot of really great questions already, and I've kind of been documenting them here. So let's go ahead and get started. So across the board, there's a few questions just around how credentials and authentication's handled for Terraform Cloud. If you could talk a little bit more about that, Rosemary, where credentials are handled, how they're handled, and authentication with the backend.
Yeah. So credentials to Terraform Cloud are handled via a token. So you will set up a token, and that is something you set up as part of your Terraform CLI. So there's a CLI file called .terraformrc, and basically it will offer you the ability to grab that. It's like an API token, and it will make API calls directly up there. In terms of the credentials inside Terraform, any credentials that you mark in Terraform Cloud as sensitive, those are actually stored in a Vault backend. And so they're all encrypted, in transit encrypted at rest. And really the workspace itself just is retrieving that from Vault specifically. So overall, the credentials are for Terraform Cloud itself, API related. and the credentials for any provider you might be using, such as Google, AWS, etc. All of those are encrypted on the backend.
Awesome, thanks. And I believe there's also additional documentation on our doc site that will go into detail about how these work, credentials and authentication works, for those of you who are interested in learning more. We've also got a lot of questions about just the features that will be free versus paid. So just to clarify, everything that Rosemary has shown and gone over in this webinar, those will be made free with the general availability coming in September. In terms of paid feature sets, we will be announcing that later down the line. We haven't reviewed any of that in this webinar, but that announcement will be coming, and there will be additional sets of features with that. Another large set of questions we got was around integration with Azure DevOps. And so, Rosemary, I'm not sure if you're aware of this, but at least for now, our PM and engineering team is looking into integration with Azure DevOps currently, and it's pretty high priority for the team. Okay, let's take a look at some other questions here. How is Terraform Cloud different from Terraform Enterprise?
So effectively, Terraform Cloud is very similar to Terraform Enterprise. However, Terraform Enterprise required licensing. It required an amount of sort of setup, right, from an organization standpoint still. Even if it was hosted for the better, for part of the better of its lifetime, right, as part of a cloud offering. So Terraform Cloud is sort of like a low step up. If you, let's say, are starting to collaborate, that was sort of a barrier to entry for a good number of people for Terraform. They didn't want to set up all of the bootstrapping and automation that went around it. So Terraform Cloud is sort of a piece of that to say, okay, here's a start, right? If you're looking for a way to collaborate more easily and you're looking for a way to get started with Terraform within your team and spend less time doing all of the setup and the automation around it, it's a good option as well. So that's kind of the bigger difference. It's just saying, hey, this is maybe a start for those who want to begin using scaling with Terraform. And then if, let's say, you start to reach bigger scale, then the idea is maybe you might consider Enterprise, but Terraform Cloud is a perfectly suitable option.
Yes. And we will be announcing the full set of features that will come along with our Terraform Enterprise versus Terraform Cloud versus Terraform paid feature sets. I know there's some questions in here just from folks who are paying for Terraform Enterprise existing, but just look out for communication from us. We will be notifying you about the changes there and what's to come. Okay, let's see. We have some questions about accessing Active Directory. Let me just find those here. Does Terraform Cloud have integration with Active Directory?
So currently it does not. You'll have to create organizations and users and teams based on the sort of the automation that you might have to do right against the API. There may be some future feature integration with Active Directory, although right now I'm not aware of any.
Yeah, and SSO and SAML integration is part of the enterprise product for Terraform. Awesome. Another question that we have is, are there any relevant advantages to using remote or local execution mode?
Great question. So I think that if you want to do, let's say, a remote, so the remote execution basically is really useful, at least from what I find, for when I want to run something really quickly, but it's a long running process. So some things just take a lot of time to create. Even Kubernetes clusters, Sometimes networking, right, that does take time. And in that case, I don't necessarily want to run it locally because let's say I shut my laptop down and everything stops. So the remote plan is actually really useful for when I just want to run it and make sure that it's still continuing online. The other neat part about this is that if you want to run sort of the remote plan apply, someone else can actually see that. So if you, let's say, want to check something with your teammate and say, hey, can you review this plan for me? Here's the link to the run. They'll be able to see that. It's a little bit harder to do locally because you'll be sort of copying and pasting that and maybe dropping it in a Slack somewhere. So the remote plan apply is really useful in that regard.
Awesome. Thanks for answering that. I think we'd have time for just one or two more questions, and then we can close out here. Let's see. How are organization roles like admin users handled in Terraform Cloud?
So you can configure your teams accordingly, although I'm not certain of what feature set, right, that would be as of right now. But the idea is that you would be able to control your access control list, right, based on the team. So right now, by default, if you add someone to your team, they'll pretty much be an admin unless you configure them to reduce their access. So it's very similar to how you would configure, for example, someone's access to CI, etc. Do they have run access to this? Do they have view access only? So you'll be able to configure that as well.
Okay, great. And then we have a few questions around the Terraform Cloud naming. So is Terraform Cloud the official name? Some folks are confused about Terraform Cloud versus Terraform Enterprise. I can clarify that one. So Terraform Cloud will be the official name for what a lot of the folks on the line might recognize as the previous Terraform Enterprise SaaS version. So moving forward, it will be referenced to as Terraform Cloud. In the future, Terraform Enterprise will generally only apply to private installs. Awesome. Great. So I know there's a lot of other questions that have come up that we may not have been able to get a chance to answer. Some of them, feel free to field them to Rosemary or reach out to the Terraform team directly. We do have some answers for these that we can send in kind of a follow-up to the folks who have asked them. And we'll be sure to do that. But apologies for the rest of the folks if we couldn't get to all the questions today. But we love the level of engagement and excited for the Terraform Cloud GA. Awesome. So just wanted to close out our webinar and say thank you to Rosemary and thank you to the audience. I hope everyone enjoyed today's webinar and have a better understanding of what's to come in the Terraform Cloud GA. Don't forget to sign up for a Terraform Cloud free account at app.terraform.io/signup. And once you do, you'll be able to access those features that are going to be coming available in September. And finally, as mentioned at the beginning of the webinar, the recording will be made available and it will be sent to everyone who has registered. So you can go back and comb through any of the live demo or any content that you need. Great. Thank you, everyone. Have a great day.